Well, when we talk about those groups of orbitals, like the 4p orbitals, we could call that a sublevel. The 4p sublevel has 3 orbitals in it, so this is a sublevel. And the fourth energy level, n equals 4, has 4 different sublevels: the 4s, the 4p, the 4d, and the 4f. Just getting used to the language here. The thing is, those sublevels are different energies. They do have different energy levels. So, like you might think, the S is the lowest energy, and then it goes up in energy, P, D, and F. Okay. The thing to remember is that all of the P's, all 3 of the P's have the same energy, but it's different than the others, and all of them are in the 4th energy level. I do not use this other term, but you may hear that subshell instead of sublevel. A shell is like n equals 4, a principal energy level, and a subshell is like this, a 4p or whatever. So let's look at a rule that will show us where to put the electrons into the different sublevels and different orbitals. So just kind of applying this rule is that you can have 2 electrons per orbital, but they have to have opposite spins. And we'll talk about the spins in a minute, but let's just figure out how many electrons can fit in each sublevel. How many electrons can fit in the 1s sublevel? And the 1s has 1 orbital, and you can have 2 electrons per 1 orbital, so it can fit 2 electrons. Okay, how many electrons can fit in the 2p? Well, we've learned that p orbitals come in sets of 3, and 3 orbitals can hold 2 each. That's 6 electrons can fit. What about the 5d sublevel? Well, d orbitals come in sets of 5. And so if you have 2 electrons in each one, that's 10. And this one, an important point, if it's a 4p orbital versus the 2p orbital, the number of electrons is the same because it's still p. P come in sets of 3, so 2 electrons each. Okay, let's talk about that spin. Electrons spin. This is electrons are spinning kind of like the Earth is spinning on its axis. Electrons are spinning, and because they have a charge and they're spinning, they create a magnetic field. So each electron has a magnetic field, which means it has a north and a south pole. Well, magnets have north and south poles for the same reason. And you know, if you're trying to put 2 magnets together, if you put them like north to north and south to south, aligned the same way, they will repel. But if you align them north to south and south to north, then they'll actually attract each other. And this is important for the electrons because if their spins are the same, then they will repel each other. But if their spins are opposite, then they'll stick together better. Remember that electrons are still negatively charged, so they do repel each other, but having this effect of the magnetic fields helps 2 be in 1 orbital. Okay, so if you have 2 electrons, they have to have opposite spins, and so to show that they have opposite spins, we use the arrows. Having an up arrow and a down arrow means that they have opposite spins. So the arrows represent the electrons. The direction up and down represents the spin of the electrons. So this is how we show that we have 2 electrons with opposite spins. The circles we've seen before are that represent orbitals. And this down here represents the sublevel. In other words, the value for n and the orbital type.